All right, we're back. We're still on page 6 of notes 18 of Calc AB. We're talking about average value. We're doing old AP free response questions, which really is the way to get a good score on the AP exam. Just go back, do all the free response questions you can find. If you search for them, you can find pretty much all of them, and just get going. I mean, the older the question, the kind of earlier in the year you can probably do it, because they used to kind of mix fewer topics together, and now the questions are like, did you understand day 1, day 55, and day 100? Like they're very mixed up, but they used to be a little more discrete. So let's see this one. So 1979, I was actually alive for this one. If you watched the last video, I was not alive for the previous one. I was alive for this one. You can work some things out potentially from that. All right, so the function is x cubed plus ax squared plus bx plus c. Has the following properties. The graph has a point of inflection at 0, -2. I think that tells me two things. And then the average or mean value of f of x on the closed interval is from 0 to is -3. So that is like the old-timey way, right? So on the modern exam, they would just say the average value. They would not throw mean in there. They'd say the average value of the function on the closed interval is -3. And you'd be like, yep, I know exactly what that means. They used to mix that word up. I don't know. So anyway, let's see what we can do. So, all right, the graph, determine A, B, and C. So the one thing that I think that we know is from this piece of information, we actually know two things. It's a polynomial. So if there's a point of inflection, so from 1, I know that f of 0 is -2, right? Because they tell me that there's the point 0, -2. It's a point of inflection, but it's also a point on the function. So f of 0 must be -2. Since it's a point of inflection, and this is a polynomial, so you know there's not some like weird thing going on where like the second derivative is undefined or whatever. We definitely know that f double prime of 0 is 0. So let's combine that and see what it tells us. So using from 1, we know, what do we know? How would I denote this so that I'm not like doing, I guess I'll use capital. So from 1, we get this, and then we also get this. Okay, maybe, I don't know. Anyway, so from this, I know that f of 0 is -2, which if you look at it, that just means that c is -2. And then using 2, f prime of x is 3x squared plus 2ax plus b. And then f double prime is going to be 6x plus 2a. And f double prime of 0 equals 0, which means that 2a equals 0. So a is 0. A is 0? Oh yeah, a is not the coefficient of x cubed. I always think like it should, I feel like it should be ax cubed, you know. So I know a and I know c. What else do I know? Has the following properties. F of 0 is -2. So then do I use the average value thing, I guess? What more? Yeah, I think I have to, because I didn't use the average value yet. So at this point, I know that f of x is x cubed. A is 0, so there's no x squared. We don't know what b is, bx. And then we know c is -2. Okay, so I'm going to do integral over interval. So we'll be using 2. The integral from 0 to 2 of x cubed plus bx minus 2 over 2 minus 0 equals -3. So that's 1/4 x to the 4th plus 1/2 bx squared minus 2x from 0 to 2 equals -6. I'm hoping this is not super hard. Oh, yeah, so the 0 makes things kind of nice. So when I plug in 2, I get 16 over 4 is 4, plus 4 over 2 is 2b, minus 4. And then when you plug in 0, you just get zeros on the left, equals negative 6. So 2b is negative 6. B, I think, is negative 3. Okay, so what was I supposed to do? Find the values of A, B, and C. So I think I did that. So C is negative 2. I think A is 0. I think B is negative 3. Okay. Used all the information so far. So now what's the next thing? Determine the value of x that satisfies the conclusion of the mean value theorem for f on the closed interval from 0 to 3. Okay. So let's write f of x. So f of x is x cubed. A was 0. B we got was negative 3, so minus 3x. And then C we got was negative 2, minus 2. Is continuous on the closed interval from 0 to 3, differentiable on the open interval from 0 to 3. Therefore, by mean value theorem, f prime of C equals f of 3 minus f of 0 over 3 minus 0. Okay. For some C that's an element of the open interval, 0 to 3. All right, now let's like do it. We justified that we're allowed to do it. So f prime of x is 3x squared minus 3. So I guess 3c squared minus 3 equals, what's f of 3? 9 minus 9 minus 2, negative 2. F of 0 is also minus 2. So negative 2 minus negative 2 is plus 2. And then over 3, but that's just 0. So c squared is 1. So c is plus or minus 1. Therefore, but then also, well, how should I write this? But c has to be an element of, since c is an element of 0, 3, c equals positive 1. I think that's the answer. I'm going to do it on the calculator, even though 1979, 0% chance that you were going to use a calculator on this, because calculator had not come into being quite yet, really. At least not this type of calculator. Where'd this go? What? Oh, I'm on the wrong page. Hold on now. I'm moving it, so I'm going to, okay, should be back. Man, I hope it's back. All right. So let's see, how could we do this if we like had a calculator from start to finish? F of x cubed plus a times x squared plus b times x plus c. So the multiplication symbols that I'm putting between the a and the x squared and the b and the x are crucial, because otherwise the calculator thinks that like ax is a variable because it doesn't care. So those are not optional, they must be there. So what did we do? We did kind of like a solve. I don't really know. F of 0. I don't know if this is going to work. And the second derivative. So the second derivative of x with respect to x of f of x equals 0, comma a, and then outside I'm going to say such that x was equal to 0. I don't know. I feel like this shouldn't work. This will let me solve for a and, well, I got a is 0 and c is negative 2. I didn't get any information about b, so let's do f of x such that this is true. And then I'm going to store that as f of x. Okay. Then we knew that the average value, so that's the integral, integral from 0 to 2 of f of x with respect to x over 2 was equal to negative 3. Okay. I don't really know how it solved that without me saying like solve, but does it just do that? 3x equals 5? Nope. I don't know. I don't know how it's all. I don't know why it solved that. Whatever. B is negative 3. Good job. So now I'm going to do f of x such that b is negative 3 and store that as f of x. Okay. And then the final thing was I want to try to solve the derivative of f of x. So this is, I like going back and seeing how the calculator would have handled old questions. I mean, I think that's an interesting thing to do. But also, like, it increases your calculator skills, and that's like really important. So we want to solve this for x. But I need to stipulate that 0, 3, 0, 3. Square root of 3. All right, so I got that wrong. So why did I get that wrong? 3c. Why did I get that wrong? 3c squared minus 3. What? What's the derivative of f of x with respect to x? Okay, what's f of 3 minus f of 0? F of 3, oh, cubed. Oh, yeah. All right, let me go back. So I was like, good thing I decided to do this on the calculator. I was getting it wrong. So the place where I got it wrong was, oh man, must be so frustrating for some of you. Here, when I plugged in, well, here, this value is wrong. I don't know what I plugged into. Oh, I think maybe I plugged, I don't know. I think I don't know. I just didn't cube it. So 3 cubed is 27. 27 minus 9 is 27 minus 9. Let's use red. 27 minus 9 is 18, and then minus 2 is 16. So 16 over 2. Nope. 16 plus 2 is 18 over 3 is 6. 6 plus 3 is 9. 9 divided by 3 is 3. So here we get plus or minus radical 3. And then since we're supposed to be between, oh, look at that. Okay, so good thing I decided to use a calculator because I got it wrong. All right, but we fixed it by looking at the calculator. Maybe I should think twice when I'm like doing these things, double check, but who knows? Anyway, super good problem, as you saw. You have to use all the given information, figure some stuff out, try not to make a silly algebraic mistake. Yeah, what are you gonna do? But anyway, I'm gonna end the video here. I'll be back in the next one to do the next page. So I will see you there.